Hello dear students, welcome to the course of Programming Fundamentals with Python. I am your instructor Kifayatullah. This is week number 5 of our course, and in today's lecture we will be talking about the Python operators. In the Python language we have different types of operators available, and we will be exploring them in much detail in this lecture. So here is a brief overview of the topics that we are going to cover in this lecture. As usual, we will start our lecture with general objectives. That is, what are the outcomes of this lecture? What are you going to learn at the end of this lecture? First, we will learn about operator, what operator is, how it performs over the data, and then we will see categorization. We can actually divide these operators into different categories. For example, arithmetic operators, assignment operator, comparisons, or relational operators, and then we have the logical and bitwise operator. After that, we will see the priorities of these operators. For example, if you have more than one operators in an expression, then which operator is going to be evaluated first? And similarly, we have associativity of the operators, which mean that if you have two or more operators of the same priority, then in that case, what operator will be evaluated, which operator will be evaluated first. Finally, we will see different types of numbers available in the Python. So the objectives are that at the end of this lecture, you will get familiar with different types of operators. You will come to know about the different categories of these operators, and then it will enable you to write simple Python programs and perform certain types of mathematical and logical operations over the data. Or in other words, you will be able to manipulate data values by performing different operations over them. And finally, you will learn about different types of numbers that are available in the Python language. Okay, so what an operator is? Actually, they are symbols, but these symbols perform certain tasks or certain operations which could be related with mathematics, logic, or sometime with operation of the individual bits, like the case of bitwise operators. So these symbols, which are well known, some of them are well known to you, and you have already used them in mathematics or other courses like plus, minus, greater than, equal, less than, etc. So all these operators are actually, all these symbols are actually known as operators. Operator actually manipulates the data, or you can say they can actually operate over the data, and the data on which they operate are referred as operands. So we have two things. For example, in the expression, the 4 and 6, which are constant, they are examples of operands. And the plus, which is a symbol, is operator in this case. And this operator actually operates on these values. So 4 and 6, which are the integer constant, they are example of operand, and plus in this case is an example of operator. In Python, different types of operators are available, and we can categorize these operators into different classes. The first category of operator is called arithmetic operators. As the name indicate, they are the basic operators which are available for performing mathematics related operation. For example, addition, subtraction, multiplication, division, modulus, exponent, and floor division operators. In the table, you can see the description against each operator that we have available, and then you can see some examples with the expected results that we achieve, we get after applying the operators on the operands. So the first is the plus operator. It actually adds two operands or two values or two data items and will produce their sum. For example, p plus q. Here in this case, the value of p is 2 while the value of q is 3. So 2 plus 3 will will give you a 5. Similarly, the subtraction operator or the minus operator, it actually subtracts the two operand and will produce the difference among them. For example, if you subtract the q from p, like 2 minus 3, you will get a minus 1. For multiplication, we have a different type of operator available, which is the steric, represented by the steric. So whenever you encounter a steric in Python, it will actually represent a multiplication operator, and it actually produces the product of the two operands. For example, p multiplied by q, that is 2 multiplied by 3, will give you a 6. Then for division, we have the slash operator. It will actually produce the quotient of its operand. When you divide a number by another number, and what you get in the quotient is actually done by the operator, which is represented by the slash. So for example, q divided by p, the value of q is 3. If you divide 3 by 2, which is represented by p, you will get 1.5 in the quotient. Similarly, for remainder, we have another operator which is known as modulus operator, and it is represented by the a percentage or ampersand sign. It actually divides the left hand operand by the right hand, and what is it return actually a remainder after the division. So if you divide q by p, you will get a 1 in the remainder. For exponent, we have to use double steric. So do not confuse single steric with double steric. Single steric is for multiplication in Python, while double steric is for exponent. Exponent like power is also called power. For example, 2 raised to the power 3 will give you 8. 2 multiplied by 2 multiplied by 2, or 3 times 2 is equal to 8. And finally, we have the double slash, which represent the floor division operator. It also return the quotient of the division, but in whole number, or in it actually return the integer part. You can also say that it actually apply the floor mathematical function over the quotient, and if it has a decimal point, then the decimal point is ignored. So these are arithmetic operators. Dear viewers, let me tell you one thing, that in this course, actually I am working on two different streams. One stream is specifically dedicated to the theoretical concept, while the second stream is fully dedicated to the practical implementation of the concepts. So both the weeks are parallel. The concepts that you learn in the theory you will get the same thing implemented or in practical in the same week. For example, this is week number 5, and week number 5, this is the theory class. Similarly, in week number 5 practical class, you will see the implementation of all these operators. So don't be confused that I am only focusing on the theory. If you are interested in practical sessions, please go to the appropriate week of the practical sessions, which are also shared on this channel. The second category of operator is actually assignment. One of the assignment operator you already know, and that is the equal sign. Equal sign is actually an assignment operator, and in Python, this assignment operator represented by equal sign is known as simple assignment operator. Here is an example of the simple assignment operator. We want to assign a value that is 5 to a variable that is x. So now the x contain the value 5. These are the comments. And then we increment the value of 5 by 1. Or you can say we are actually adding 1 with 5. So 5 plus 1 you will receive 6. What we are doing with the help of this assignment operator, we are actually assigning the resultant value, that is 6, to the variable x. You can raise a question like, x already have a value that is 5. How we can assign a value to the same variable? You can actually assign a new value to the same variable, but in that case the previous value will be replaced. So now the new value of x is going to be 6. So if you print the value of x, it will display 6 instead of 5. And this is an illustration of the assignment. simple assignment operator. Beside from simple assignment operator, we also have compound assignment operators. In Python, the compound assignment operators actually combine the assignment operator, the simple assignment operator, with another operator like plus, like minus, like static, like a slash, etc. So when you combine assignment with another operator, it is referred as compound assignment operator. But it has a specific format to be written in. For example, you have an expression like x is equal to x plus 1. In this case, we are actually using simple assignment operator, but you can also write it in another form, and that is x plus equal to 1. In this case, in this expression, plus equal is referred as compound operator. Here you see two operators, plus along with simple assignment. Combinedly, they are called compound assignment operator. The difference is that here you have to use the variable 2 times, while here we only use it once. Actually, Python knows what operation it is required to perform after seeing an expression which contains the compound assignment operator. This table represents all the possible compound assignment operators. So you can actually combine it with the addition, with the subtraction, multiplication, division, exponent, floor, or even the remainder operator. In this case, it will actually do the addition. Here it will do the subtraction, here the multiplication, division, etc. We will see examples in the theory, in the practical sessions, and we will see the actual implementation of all these compound assignment operators in the practical sessions. Then we have the comparison operators. When the values of two operands or two data elements or two values are to be compared, then we have to use the comparison operators. For comparison operators, remember that the output, the result of such operators is always a Boolean value. Boolean mean either true or false, or you can say either 0 or 1. So the operands on which we can actually apply the comparison operators, they could be numbers, they could be string, characters, or even Boolean values itself. Here is a list of all the available comparison operators. Okay, for equal, we have to use double equal sign. Why? Because the single equal sign has been reserved for the assignment operator. So for comparison purposes, in order to find the equality, we need another operator, and for that the Python use double equal sign. It will actually compare the values of two operands, and if they are equal, it will return a true. Similarly, not equal is represented by this sign, this symbol. It will compare the value of two operands. If they are not equal, it will return a true value. For example, p is not equal to q. In this case, the value of p is 10, the value of q is 20. Compare 10 with 20. So here I say that, hey, 10 is not equal to 20. That is true. It will return a true. And then for greater, like mathematics, you have to use this sign. For example, I say p is greater than q, 10 is greater than q. So in this case, the output is going to be false, because 10 is not greater than 20. However, if I say 10 is less than 20 or p is less than q, that is true. The output in this case will be true. You can actually combine two operators, two comparison operators. For example, greater than or equal to or less than or equal to. It means that if any one of these two conditions becomes true, the output will be true. Similarly, it means that if any one of these conditions become true, the output will be true. How? Let us see an example. The value of p is 10, the value of q is 20. So let us see. Apply this condition over p and q. P is greater than q. No, p is not greater than q. Okay, let us check another condition. P is equal to q. No, that is not equal. So both the conditions are false, So the output is not true or false. Now let us check here. Apply the same comparison operator with the same data, less than or equal. P is less than Q, 10 is less than 20. Yes, that is true. P is less than Q or 10 is less than 20. Okay, now apply the second condition. P is equal to Q. 10 is equal to Q. No, that is false. Even though 10 is not equal to 20, still 10 is less than 20. So if in this case, if one of the condition becomes true, the output will be true. So here you can see that it is true. Another category of the operator is known as logical operators. Logical operators are actually used for comparing the logical values of their operands, and it actually return a logical value, and logical values are true or false or boolean values or were 1 or 0, you can say. So the result of a logical operator is always a boolean value that is either true or false. Let us see some examples and tables in table of the logical operators. In Python we have three logical operators, and they are logical AND, logical OR, and logical NOT. Right? AND is represented by AND, OR is represented by small OR, and NOT is represented by small NOT. In order to understand the logical operator, it is important to understand the concept of a truth table. Maybe in some other courses you learn how the truth table are created, but for understanding the concept of logical operators, it is important to understand how things happen when we apply these operators. Let us see. You have two variables P and Q. Actually, we have four possibilities. Both are true, both are false. First one is true, second one is false, or first one is false and second one is true. These are the four possibilities. After applying the AND operator on P and Q, let us see the output. In case of AND logical operator, the output will be true if both the values are true. From here you can see the value of P is true, the value of Q is true. Both are true, so the output is true. In other cases, the output is false. If both are false, the output is false. If any one of them is false, then still the output is false. The output is true only if both the values are true. And that is the first case. That is logical AND. In simple word, that is true if both are true, otherwise false. Now let us come to the second logical operator, that is the logical OR. Logical OR is different from AND in the sense the output will be true if both are true, just like in the case of the AND, and also it will be true if any one of them is true. For example, here P is true, Q is false, but the output is true. In the third case, P is false, but Q is true, so the output is true. Only false in the output if both P and Q are false. It is like opposite. In the AND, we have only one true, while in the OR, we have only one false. Or you can say in the AND operator, we have three false values, while in the OR operator, we have three true values. When it is going to be true, in case of AND operator, if both the input values are true, then the output will be true. And in case of OR operator, the output will be true if both are true or any one of them is true. Or you can say the output will be false if both of them are false and true otherwise. We also have the NOT operator, and NOT operator is like opposite. You can apply it over a single value. If the value is true, it will convert it into false, and if the value is false, it will convert it into a true value. Similar to logical operators, we have bitwise operators. Bitwise operators actually operate over individual bits, or they can perform their operation bitwise or bit by bit. So in this case, our operands are actually a sequence of bits, that is zeros and ones. For example, let me tell you that we have different number systems available. The one which we use in our daily life is the example of decimal number system. Computer use binary number system, and we also have the octal and hexadecimal number systems. And you can convert any number given in any number system to any other number system. So you can easily convert a decimal 10 to a binary sequence of digits or bits, that is 1010. And then now you can apply the bitwise operators on this data which is in binary form. Actually, we have different bitwise operators available. Some of them are here. We have a binary AND, binary OR, exclusive OR, binary ones complement, left shift and right shift. Let us see them one by one. Binary AND is exactly the same thing as logical AND in terms of operations. What is that? That if both the bits are true, the output will be true and it will be false otherwise. But here the true is represented by 1 and the false is represented by 0. So if you add 0 with 0, you will get 0. If you AND 0 with 1, you will get 0. If you AND 1 with 0, you will get 0. You will get 1 only if both of them are 1. In other words, if both of them are true, the output will be true. Otherwise, it will be false. And it is represented by this ampersand sign. Then we have the bitwise OR operator. We actually apply it on individual bits 0 and 1s. And in this case, the output will be true if both of them are true or if any one of them is true. It will be false only if both of them are false. So in this case, you can see that the value of P and Q, if both of them are true, then the output is true. If any one of them is true, then the output is still true. But if both of them are false, then the output is going to be false. This is the bitwise OR operator. And then we have something new. There is the exclusive OR. For the concept of exclusive OR, actually the concept is like this. If both are true or both are false, the output is going to be false and true otherwise. For example, if both are 0, then the output will be 0. If both are 1s, then the output will be 0. If one is true, one is false, then the output will be 1. So it is important to remember that in exclusive OR case, the output will be 1 if both are true, or the output will be 0 if both are true or both are false, and the output will be 1 otherwise. And it is shown in the truth table. And finally, we have the a binary ones, that is like the NOT operator. It will convert the value of 0 to the value of 1 and the value of 1 to the value of 0. We also have binary left shift and binary right shift. The binary left shift operator will shift the two leftmost bits to the right position, while the binary right shift operator will actually shift the two rightmost bits to the other end. I'm saying 2 bits. Actually, you have to specify the number of bits that you want to shift. Today we are dealing with binary numbers, binary digits, so that is why I say the word 2. If things are not clear, let us see some examples. Here we have stream of bits, sequence of bits. 2 streams represented by A and B. These are numbers in binary form and these are the numbers, representative numbers in the decimal form. If you apply AND operator and bitwise operator over these two values, then you can see the output. Remember, if both are true, then the output will be true, otherwise it will be false. In case of OR operator, the output will be true if both are true, and it will be true if any one of them is true, and it will be false otherwise. True is represented by 1, while false is represented by 0. In case of exclusive OR operator, the output will be 0 if both are true, like this, and the output will be 0 if both are 0. So if both the values are same, the output will be 0. If both the values are different, one is 0, other is 1, or one is 1 and the other is 0, then in that case you will get a 1. So both are same, 0, both are different, 1. That is the exclusive OR. One's complement is simple. If it is 0, convert it into 1. If it is ones, then convert it into a 0. Here we have the left shift operator and the value of the shift is 2. So you have to shift the two leftmost bit, which in this case is 00. You have to shift them to the other end. Move the bits forward. You will get 1 1 1 1 0 0 and 0 0. Right shift is opposite. You have to shift the two rightmost bit, which in this case is again 0 0, to the other end, and then you will get 1 1 1 1 0 0 0 0. Okay, after studying the operators, different categories, different classes, let us shed some light over the precedence of operators, or you can say that the priorities of the operator. Actually, it determines the way in which the operators are evaluated. In very simple word, any operator with high priority will operate over the operand first. But if two operators of the same priority are in an equation, then you have to follow the rules of associativity. And the rule is that you have to go from left to right. All the operators that encounter first from the left hand side will be evaluated first. Now the question is that which operators got higher priority than others. So here is a complete list. At the top we have the parenthesis. Anything inside the parenthesis is going to be evaluated first. That has the highest priority. Then we have the exponent, which is on the second number. And then if we talk about the arithmetic operator, by keeping things simple, then the multiplication, division, remainder, and quotient, they have the third priority, highest priority, higher priority. And then after that we have the plus and minus, which have the lower priority or the lowest priority in the arithmetic operator. Here it is important to note that static, division, remainder, they actually have higher priority than plus and minus, but they are siblings of each other, therefore they have the same priority. So if in an equation you encounter a static, a modulus, and for example a division operator, because they have the same priority, then you have to evaluate them from left to right. The one which encounter first is going to be evaluated first from the left hand side. Similar is the case with the plus and minus. They are siblings of one another. If you encounter them in an equation, then you have to evaluate the operator first which encounter first. We will see examples on them in the practical sessions. Okay, in Python the numbers can also be categorized into different categories or classes. We have the integer type numbers. Integer are actually the whole number integers which do not have any floating point or they do not have any decimal point. They are in whole number. So they are represented by int. In most of the programming languages they are called integers. For example, 10, 100, 1000, 2000, all of them are examples of integers. If any number have a floating point in them or a decimal point, they are called floating point constant or numbers or even real numbers, because they are not the integer. They are so called real number. Why the floating point is called floating? Because the point itself float among the numbers. Sometime you will encounter a pointer after 10, sometime after 100, sometime after 1000, etc. So the point is not fixed, you can say. You can apply all these operators over the integers, over the floating point. And floating point in Python is actually represented with the word float. In most of the programming languages, we actually use the keyword float to represent a floating point number or constant. Python also has support for complex number. Being a programmer, it is rare for you to work with the complex number. They are actually used in scientific calculations like engineering disciplines, etc. Normally, we do not require to work with complex number. But complex number is any number that have a real part in an imaginary form in the form of a plus bi. So here a is an example of the real part, and what we see on the other side of the plus sign is an example of imaginary part. Actually, the I represent the imaginary part. I can also be represented by J. It depends whether you are using mathematical notations or engineering notations. So Python has support for the for such type of numbers as well. And finally, we have the Boolean values. Boolean values are actually a type of integer values. For example, in integer number system, we have 0 and 1s. And similar, the Boolean values are represented by 0 and 1. 0 is for false and 1 is for true. Okay, one more thing to remember, that whenever you perform an operation over the or the sequence of bits, the output of that is going to be true or false. So in Python, true is represented by capital TRUE and false is represented by capital F and then ALSE. Okay, so this was about today lecture. If you want to practice programs related with this week, please go to the Python practical session of this week. See you there. Goodbye.